Well, thank you guys for coming. My name is Andrejs. I'm an engineer at Hazelcast, and I want to talk to you a little bit about powering real-time web applications with in-memory data grids, of which Hazelcast is one. So what are in-memory data grids? It's kind of a broad question, but in general, for the purpose of this talk, they are distributed and in-memory data structures like maps, caches, lists, counters, and others. They also have queues and topics, a distributed executor service, so you can run your tasks on a large number of machines or near your data, up to you. And also includes in-memory data processing like MapReduce and aggregation. So that's all great. That's a really great set of tools. But what about web applications? Well, it turns out they in-memory data grids are very commonly used together with web applications. And the common use cases that we see is session replication. So you have multiple application servers. You want to keep the sessions even when one of the nodes dies, or the load balancer throws it to a different server. Second one is database cache. So if the database is slow, you want to cache the query results for fast response. And in general, for clustering and high availability of your applications. So this used a lot, it's very common, but what if we want to go beyond that? I want to see an application which is dynamic and real-time and updated. And by real-time, I mean in the webby real-time sense, not in the sense they has to respond within a certain time. Yes. So there are some features which can help us build applications like that. So queues and topics is not that new, because especially if you're coming from JMS world. But what I really want to zoom in is entry listeners and continuous query in data grids to create a dynamic, real-time, live updating web application. So let's start with the map. So a distributed map in Hazelcast is like a map in Java, implements the map interface. But when you put something in, it gets distributed around the cluster. So your data is replicated and sharded. And it's as easy as that. I create a new object, I put it in, it's stored somewhere on the cluster. So that's great. My data is all stored somewhere. But then I can do one interesting thing. I can add a listener. So I can say, call me back when something is updated in that map. Anywhere on the cluster, when someone puts something in, let me know. Well, cool. Yeah, it's easy. Yeah, why not? That'll be helpful. But we can go even beyond that. We can say, maybe I'm not interested in all data. Maybe I'm not interested in all my website visitors. I can say, call me back only when the visitors are coming from operating system OS X and they are returning visitor, for example. It could be any field. It could be a Fluent API predicate. It doesn't have to be a SQL predicate. But for the sake of this presentation, it will do. And that's really it. A few lines of code, and you get a callback when something matches the predicate in the cluster. OK, awesome. So now we need to get to the web part. So for the purpose of this talk, I'm going to involve Vertex. So Vertex is one of my favorite web frameworks right now. It's great because it's polyglot, event-driven, easy to scale, has built-in WebSockets. So that's what we need. What's even more, that the WebSockets are abstracted behind an event bus. So I just need to publish a message to the event bus, and so the subscribers will get the message whether they're on a browser or on another JVM. So awesome. So that's really simple. So let's combine those, continuous query and a web framework. So I will create a demo application, which is a dashboard for my website visitors. So I'm going to be storing visitors. I'm not going to have a live database, live website. I'm just going to use a generator for the demo. Then we're going to get a continuous query to look for specific visitors. I will publish the events to a Vertex event bus, which will be received on the client side in the browser, and then we'll update the page in real time. And it's a Java 8 and Vertex 3 application. Another interesting thing is that the Vertex embeds Hazelcast for its clustering. So we can use either that embedded instance of Hazelcast, or we can connect to a new one. For this presentation, I'm just going to use the one that's embedded, because it's simpler. So what happens? So here on the server side, we have the same code. So I have my predicate, I have my event listener. But when I get a callback, I say to Vertex, just publish it. So just send it to whoever is listening. So all I need to do is really convert the event to JSON, which I do based on my visitor object, and I tell it which address to publish it to. That's it. Simple. What's happening on the client side? On the client side, JavaScript is simple as well. Vertex provides us with a JavaScript API as a JavaScript library. We can say, just subscribe to this channel. My channel is visitors, where I receive the JSON visitor. And then I can do what I want. I can update the page in real time, as soon as updates happen. And that's basically it. Demo time. So I have a small application with my generator, my web server, and my publisher, which publishes to Vertex. Sorry, it was running already. Let's start a new one. You can see the Hazelcast instance is up and running. So all I did really is I took a dashboard application, dashboard template, and I connected it to Vertex, subscribed to the channel. My generator is generating new visitors, putting in the map. The map is listening with a continuous query and publishing to a Vertex channel. As soon as updates happen, my page is updating in the table and in the chart. So hopefully I've demonstrated that with really few lines of code, we can create something dynamic and powerful. So I guess all in all, my main point was that in-memory data grids, I think, and web apps are a really great fit together, and they very easy to use with the tools we have. Which enables us to create powerful real-time web apps. So yeah, if you have any questions, feel free. Or you can also find us at the booth later on. Okay, thank you.